All right, we're going to keep working with SOH. This time we're working on application problems. There are a few posted on Schoology, and we're just going to work through two examples together so you can get a feel for it. The first thing with application problems is you always want to draw a picture. It's the best way to visualize the problem and see the setup of what you're going to be doing. So for this first one, a wheelchair ramp is 4.2 meters long. It rises 0.7 meters. What is the angle of inclination to the nearest degree? So if we have a wheelchair ramp that's going up like that, and it's 4.2 meters long, then it's risen 0.7 meters. So if this is the ground, this is our right angle, and we want the angle of inclination. You may be more used to the term angle of elevation, but it's the same thing. So we want to find theta, and we have this opposite side and the hypotenuse. So sine is what we'll be using, and sine of theta is opposite over hypotenuse, so 0.7 over 4.2. Take the inverse sine of both sides to cancel out sine on the left. So these cancel out, you're left with theta on the left, and on that right, you can just put it directly into your calculator. And you get 9.594 degrees. I know that seems small for an angle, but we are dealing with a wheelchair ramp, so if you think about it, they're not very steep, so that would make sense. And that is the final answer. Now, this one's a little longer, it's a little more complicated, but I'm confident you'll be able to do it. It says an airplane is flying at an altitude of 6,000 meters over the ocean directly toward a coastline. At a certain time, the angle of depression to the coastline from the airplane is 14 degrees. How much further to the nearest meter does the airplane have to fly before it is directly above the coastline? So again, we're drawing a picture. I am no artist. I don't expect you to be either. So I'm just going to use a dot as the airplane. And you'll have to just imagine that I've drawn an airplane here. And we have the ocean at the bottom, and that airplane is 6,000 meters over the ocean. So that's the altitude. We know that there's an angle of depression. So this is the skyline. And if you recall, angle of depression means that this is 14 degrees. And we want the plane to reach the coastline. So it's going in this direction. And this right here is going to be the coastline. So we want to know how long it's going to take to go that distance. So we're going to be solving for x. Now the first thing we have to do is we have to get an angle that's actually inside this triangle. So this angle right here is what we'll be working with. So that's going to be 76 degrees. And we want to find this, the opposite side, using this, the adjacent side. So we'll be using tangent. And we'll get opposite over adjacent, so x over 6,000. Multiply that 6,000 over. To find x and plug that into the calculator. And you get that x is 24,065 meters. So yes, the problem was a little longer, a few more words, but it was the same problem that you've been doing for the past couple of days.